All right.
A lot of money. With a big house. With money.
A lot of them are. What do you mean? Yes, they do. Well, yes, they do. I've always got cut off like yes. These two.
Actually, no, you're good. Sorry, I'm thinking of myself. Part 2. All right, so
I was gonna say, didn't I write your homework?
we're continuing our look at solving trigonometric equations. We're just going to see like a little, more advanced kind of problems here. All right. So let's take a look at these. All right. For example, here, I'm just going to jump right into an example. Sine squared x plus 3 sine x minus 4 equals 0. Again, we're gonna stick to solving for 0 to 2 pi, I think. Okay. Just stick to solving for 0 to 2 pi. And then we'll concern ourselves with not doing that a little bit later, but right now let's stick to that. Okay. So ideas here. What would maybe be a good way to start kind of tackling this? Any ideas? So yeah. Back to like a quadratic. Yes, exactly right. So like, what kind of clues you in here that would be like a possibility even?
It's like a power that's double the middle term.
Okay.
And then the constant at the end.
Yeah, that's pretty good. Yeah, exactly right. I mean, you can see here we have something squared, right? Plus 3 times that very same something, and then minus, our number here, there, 4. Okay? So, exactly right. We're going to factor this thing. Okay? So, like a quadratic, which means we're going to have 2 kind of binomials here. Since we want sine of x quantity squared, we're going to have sine of x and sine of x there out front. And then we can come up with some numbers here, right? 2 numbers that multiply to what? -4, and add to make 3. So those 2 numbers would be 4 and -1. Okay, there it is, right? So now, and we're equal to 0, which is very important, right? Because we can take advantage of the 0 product property. If we were equal to any other number over here, right? So if this number over here was not 0, if it was like a 2 or a 3, what should have been our first step? Right, move it over so it's equal to 0, right? We want to make sure the thing that we're trying to solve here is equal to 0 if we can see that we're going to need to factor, right? If we can see that factoring is going to be a strategy we use, oh my gosh, then my papers. All right, so it's like flashbacks to high school. All right, so anyway, so then we are in high school. That's okay, flashback, I guess. Anyway, so then we set each factor equal to 0, right? We'll go from there. All right, and then we get to this. That's very easy, right? Sine of x, when does that equal -4? So sine of x equals -4 when x is? Yes, Ramike. Never. That's right. Okay. Dead end. Right? Lowest, again, we're talking about just plain old sine here, right? It's just sine of x. There's no transformations, right? There's no a in front here that changes the amplitude. There's no vertical shift or anything like that. We get just plain old sine of x. Sine of x, the highest it can be is 1. The lowest it'll be is -1. Can never equal -4. So it's impossible. All right, how about sine of x equals 1, though? Is that impossible, too? No. When does sine of x equal 1, then, between 0 and 2 pi? Pi halves, or pi over 2. So there's our single solution there to our equation. 1. Okay. Questions on any of that? Pretty easy. That was, not too crazy there. All right, well, here, let me have y'all try one then. All right, so again, solve for 0 less than or equal to x less than 2 pi. Okay, so solve for the x values between 0 and 2 pi. Tangent x sine squared x minus tangent x sine x minus 2 tangent x. And we'll say that's equal to 0. All right. Go ahead, give it a try. Give it a go.
Yeah, that's a problem. That's like a very, that's a big problem.
Easy? It's not easy.
Yeah.
Oh my god.
Oh, she did.
I wonder if the rainbow line. Why?
Dude, I was so jealous when people got better passes than me. So like, you're the person who
Because I got this
0.
membership
Well, 2 pi, but we're not going to include 2 pi because 0 and 2 pi are the same position. But there is one other thing.
Do you guys remember Webkit?
I had like 70.
You just even forgot it on the first
I had it so like there was this one store in the mall.
Your one store.
No, it was like
Constant Disney store?
not the
No.
Disney store.
Negative
The
2
Disney store that FSK.
Oh,
It was like no, but like there was a whole massage parlor or whatever. And shadow.
I understand your type.
Yeah, I got it.
Yeah, it was right over there.
So do you do?
It was like a flower
No,
store.
you do
Yes.
You remember, right? Yeah, I go in there every week. Day by month. But I like Spanish. Like, I just
I
don't know
had
why
these,
it
I had the little platypus, like,
and that's not how I don't
little platypus, like, fluffy one. Platypus, I had the big one, and then child.
Sorry, I distracted her.
like that's how it went. No, I went for like the OG.
Okay, let's see what we've got here. Anna, do you have an answer for us?
I have 0 and 3 pi over 2.
0, 3 pi over 2, and also pi. Okay, don't forget the pi there because tangent is 0, both at 0 and at pi. Okay, remember, think about it this way, right? Tangent is the same as sine over the cosine. So when is sine 0? Sine is 0 at 0 and pi. So then tangent will also be 0 at 0 and pi. If you think about tangent as sine over cosine, sine is 0 at 0 and pi, so tangent will be 0 at 0 and pi as well. Okay, questions on any of this? Okay, so really we're just extending what we did on Friday with like the factoring idea. Friday we stuck mostly to GCF, right? But here we're throwing in some like quadratic kind of like, I don't know, quadratic kind of representations here and stuff, along with some GCF too. Okay, so that's that for that strategy. And there's one other kind of problem that we could throw at you here, and I'll write it up. Okay. And we'll do this one here. So again, solve for, excuse me, 0 less than or equal to theta less than 2 pi. Okay, so that'll be our work there that we're going to do. Okay, and let's say we've got cosine of 3 theta equals 1/2. Okay, so we have a new development here with this 3 in front of our theta. Okay, what does that 3 in front of theta do, transformationally speaking, to our cosine there? What is it going to do? What does that 3 in front of the theta do? Ramike, yeah? Okay, so a stretch. Actually, yes. Yes? No, shrink. Shrink by a factor of 3 here. But I know it's like weird, but yeah, it does end up being a shrink by a factor of 3 here. Yeah. But what's important is that, right, you recognize that it's going to like kind of dilate, okay? It's going to adjust our period there, all right, for cosine. And so how do we kind of take this into account? What can we do? Well, one way to kind of do this is to do kind of like a substitution. And so we can say something like, all right, well, let's use some other variable here. Let's say like u. We're going to say let u equal 3 theta. Okay, so we're just going to change the problem, maybe just to make it look a little bit nicer. And we'll say cosine u then is 1/2. Right, so we're just going to do a change of variable. All right, and see, okay, cosine of u equals 1/2. That's easy for us to answer, right? That's all like unit circle, easy stuff. When does the cosine of u equal 1/2 between 0 and 2 pi? When u is, sorry, pi over 3? Pi over 3 and 2 pi over 3, I think cosine would be negative, right? So that's second quadrant. So 5 pi over 3, yeah, 5 pi over 3, there we go. Okay, and we've kind of solved this, right? But are we asked to solve for u in this problem? We're solving for theta. So then what should we now do? Now that we know that u is pi over 3 or 5 pi over 3, what can we replace u with? The 3 theta, okay? This kind of change of variable here. All right. If you'd prefer, right, so maybe some of you guys look at this and like, Mr. Wood, why can't we just go cosine 3 theta equals 1/2 and then jump straight down here and say 3 theta equals the pi over 3 and 5 pi over 3? And you absolutely can. You don't have to like show the change of variables there if you feel comfortable jumping from here to here, right? That's fine, okay? From the cosine 3 theta equals 1/2 to 3 theta equals pi over 3 5 pi. It's fine, okay? And so then to finish solving for theta here, what should we do? What's with our theta that we need to get rid of? The 3, and what should we do to get rid of it? Divide by 3. So theta is pi over 9 now, and 5 pi over 9. But those aren't all the solutions between 0 and 2 pi. Okay? These were the solutions between 0 and 2 pi, but now these no longer are. Okay? Because, well, let me kind of step back here. So if I wanted to get more solutions from the pi over 3 and the 5 pi over 3, what could I add to the pi over 3 or the 5 pi over 3 to get more solutions? How often? Yeah, 2 pi, right? Because cosine repeats every 2 pi. So I'm going to just kind of put this over here in like kind of like a parentheses here. So like plus, multiples of pi there. Okay? So k is an integer or k element of, z like that. Okay? So originally, right, for the original, well, not the original problem, from this like manipulated problem here where I had cosine u equals 1/2, I could add 2k pi to any of these answers here and get additional ones. Okay? But then when I divided both sides by 3, guess what else gets divided by 3? That 2k pi does. And so our problem here doesn't repeat every 2 pi. we're going to repeat every 2 pi over 3. Like that. Okay? So in other words, I can add 2 pi over 3 to these angles, and they will still solve the original equation there. Okay? So 2 pi over 3, by the way, right, is the same thing as 6k pi over 9. And I changed it to 9s because we're going to be adding and subtracting there. So, pi over 9 was a solution. 5 pi over 9 was a solution. Those were easy enough, but now I'm going to add 6 pi over 9 here. So adding that to there, we get 7 pi over 9. Okay? Adding it to here, 11 pi over 9. Am I still less than 2 pi here? So again, I added, yes, I am, plus, 6 pi over 9 here to here, plus 6 pi over 9 from there to there. Okay. I'm still less than 2 pi, right? So I'm going to add another 6 pi over 9 to this, 13 pi over 9. I'm going to add another 6 pi over 9 to this, 17 pi over 9. Okay. Am I still less than 2 pi? Are we still less than 2 pi here?
Yes.
Yes. All right, so let's keep going. If I add 7 pi over 9 to this, if I add 6 pi over 9 to this, I'm going to get to 19 pi over 9. Am I still less than 2 pi? No. So these are all of our solutions between 0 and 2 pi. Okay. So that 3 complicates things a little bit, right? Throwing that 3 in front of the theta there, it complicates things a little bit. Whereas before, when we didn't have to worry about a change in our period, when we asked for the answers between 0 and 2 pi, it was just all the angles in the unit circle there. But when we shrink our period, okay, instead of repeating every 2 pi, we're now repeating every 2 pi over 3. That means when we can, that more answers fit between 0 and 2 pi there. So we have these 6 answers as opposed to just our normal, 2 kind of thing, or something like that, or 4 sometimes, I guess. Okay. So, questions on any of that? All right, so we want to be careful there with, coming up with the additional solutions, making sure we come up with the correct additional solution. So let's try another one. All right, how about 3 tangent x over 2 plus 3 equals 0. And again, we'll say the same thing. Solve for 0 less than or equal to x less than 2 pi. Is that plus 3 inside the tangent with the x over 2? No, right? You would see parentheses around it if you did, right? So plus 3 is outside. So what would be a good first step here to start solving this equation? Yeah, go ahead, Julie. Sorry. Subtract 3. Okay, and then Sydney, what were you going to say next there? Divide by 3. Okay. So again, if you're uncomfortable having to look at this, you could do like a change of variables here and let u equal x over 2, and so then you really have tangent of u equals -1, and so we can say, okay, then u must be, well, what here? Tangent of what gives us -1 in between 0 and 2 pi? Say again? 3 pi fourths is one of them, and 7 pi fourths. Very good. Yeah. Okay, but of course we're not interested in solving for u here, right? We want to solve for x. So resubstitute in x over 2 for u. Okay, and then what should we do to both sides here? Multiply both sides by 2. And so we get x equals 3 pi over 3 pi over 4 times 2, 6 pi over 4, which simplifies to 3 pi over 2, and 7 pi over 4 times 2, 14 pi over 4, which simplifies to 7 pi over 2. 2. Okay? So, what are our solutions here that are between 0 and 2 pi? What are the solutions here that are between 0 and 2 pi? Just 3 pi over 2. 7 pi over 2 is now outside 2 pi, right? 2 pi would be 4 pi over 2. 7 pi over 2 is greater than. So only the 3 pi over 2 fits inside there, so we only use the 3 pi over 2. Okay? Our period for this one, right? So again, if you wanted additional solutions here, we could add 2k pi to the, or not 2k pi, sorry, k pi. Add k pi because it's tangent. Remember, tangent repeats every pi. Okay, but then if we multiply here, it'd be plus 2k pi. So you would add 2 pi to each one of those solutions there, and they would also be then outside of 0 to 2 pi. If you want to get a triangle for more, but there wouldn't be any more there. Okay. Questions on any of that? Yes, Ramita, sorry.
How do you know it's gonna repeat every time, but for the other one, how do you know it's gonna repeat every time?
So it's a matter of knowing your trig functions, right? So sine and cosine, their period length is 2 pi. Their normal period length without any sort of transformations, but parent function period 0 to 2 pi. Tangent and cotangent, both of their periods are pi in length. They just start and stop at different points, or one full kind of wave starts and stops at different points, right? Okay? All right, you guys want to try one here? Let's give you one to try on your own. And let's do... Yep, we'll do this one. Okay, I'm going to do it like over here on this side. Okay, so same idea. Solve for... And this one I'm going to make it a little bit easier for you, I think. I'm going to try and make it a little bit easier. We'll see if it makes it work. So solve for 0 less than or equal to t less than pi. So only give me your t solutions, your solutions for t, only give me the ones that fit between 0 and pi. Okay, and then here's your problem to try. 4 sine squared 2t equals 3. Okay, like that. So again, please only give me solutions between 0 and pi here, just between 0 and pi. Whoop. Just give me the solution between 0 and pi.
Yeah, was it the crab like?
Yeah.
But
And he was like, hey, walk over to the
I don't get
okay, shit. And so what's about this like?
I used to nap.
Yes.
but you have to write them all out. Listen up. So I'm adding pi to y squared plus 5.
There's one of the
Plus 5. Yeah. Oh shoot. I thought it was
And then
How's your weekend?
Good.
That's it.
No, I didn't. I wasn't getting through.
Ben takes it.
Yeah, so that's the 2 in the first and second, but then the one in the third and fourth, when you divide it by 2, it's like that.
Either me or Ben.
So the ones there.
I'm over it.
Well, you'll just have to,
It's
I'll
just
different
win.
competition. If you
They
start
judge
with
it.
4
I'm
right
gonna
now,
win, so it's
So it's
And
rude.
then 5 over 3, divide by 2,
really.
divide by 2.
Second. I told you about it.
Sauce? Seriously? Sauce?
what are your sides?
No, I went on like 3 or 4. Because we had
No,
to-
I love going on roller coasters to like throw up.
Okay,
Like
the
there's
thing
no
is,
stopping.
even on the equipment, like it was really disappointing because I didn't get that sinking feeling that I started.
I passed out and it was so fun. So like you're on it and then like you're going so fast and then like you pass out and then you wake up and you're still down.
Well, you know that sinking feeling like when you drop?
Yeah.
I love that, but I didn't get that on any of them too. I didn't get that on any of the rides. I ate a lot.
Alrighty.
When I was in the hospital, I hadn't eaten anything for a week and I kept throwing up and I was just throwing up green. It was like my acid and my stomach.
Alrighty.
Hey, is that gonna be in the video?
Probably now,
Not
yeah.
forever.
Yes, yes. Someone can timestamp it in the comments, so they can listen. You can go back to it. Okay. All right, Andrea, you got some answers for us here for this last problem? Okay, very good. Yes. There's also a few more here, so I'm gonna address something I saw that a couple students were doing. I get what you're doing there. Okay, so I think what I saw happen is that we got like the pi over 3 and then 2 pi over 3, maybe even went out to 4 pi over 3 and 5 pi over 3 because we did have that plus or minus root 3 over 2 here. Okay, don't eliminate these two answers here at the start because they are going to get divided by 2 and they still end up fitting between 0 and pi. Okay, so your range here, I would still suggest you keep it between 0 and 2 pi here. All right, it's not until the very final then answer that you want to eliminate anything. So hold off on eliminating your answers until the end. Okay, if they happen to fall outside the 0 to pi range. Okay, in this case, those 4 solutions, when you divide them by 2, end up falling between 0 and pi, and no additional solutions. Right? There's no additional solutions there that would work. You could add pi to this, but you'd be outside then the 0 to pi range, or any of those right there. Okay? So, questions on any of that? Does that make some sense, hopefully? Because I saw several people make that error, and I just wanted to address that here. So, again, hold off on eliminating till the very end, okay, there for the 0 less equal to t less than pi there, in this case. All right? We're good? All right. If there are no questions, then let me get you guys started on your assignment. That's it. Okay. That's it. Page 394 again, but this time it's 394, numbers 33, 39 to 43, 63, 91, and these are odds.
Yeah, that was so weird.
Time flies when you're having fun.
I'm so sorry.
Can you stop the video yet?
Not yet.
Wait, okay. Watch my podcast.
Right. Wait, watch your podcast.
Yeah, I'm just gonna be on YouTube.
Oh, okay.
Yeah, with me.